Hey, what's up, future Siri toppers? If you're here to lock in some guaranteed marks for your exam, you've come to the right place. Seriously, today we're going to crack one of the most important and often confusing topics in biology, oligosaccharides. So get your notes ready and let's just jump right in.
Okay, let's be real for a second. You see a question about, I don't know, glycosidic bonds or reducing sugars, and your heart kind of sinks, right? You start guessing. Is it lactose? Wait, no, is it sucrose? I get it. This is a topic where so many students just get tangled up and lose easy marks. But that's not going to be you, not after this explainer. I promise we're going to make this one of the easiest topics you'll see on the test.
So, you might be asking, why are we drilling down on this one topic so hard? It's simple. Mastering just this one thing can mean a direct jump of 4, maybe even 8 marks in your CUET exam. Think about that for a second. That could be a total game changer, the thing that gets you into your dream college. The stakes are definitely high, so let's make sure you nail every single point. So what's our plan to make sure you get these marks?
Okay, so here's the deal. Exam setters absolutely love this topic. It's a favorite. They're going to ask you to identify different sugars, name their super-specific bonds, and tell them apart based on their properties. So our game plan is simple. We're going to hit every single one of those points head on. That way, you can walk into that exam feeling totally confident. So let's start by breaking down these sugar chains right from the very beginning.
All right, time to decode these sugar chains. We're going from the absolute basics all the way to mastery. Let's build that rock-solid foundation you're going to need.
So what in the world are oligosaccharides? Honestly, the easiest way to think about them is just small sugar chains. That's it. They're built from like 2 to 10 of these single sugar units, we call those monosaccharides, all linked up. They're soluble in water, usually taste sweet, and yeah, they're super important for energy. Pretty straightforward, right?
But how do these little sugar units actually stick together? Well, they're held by this special connection called a glycosidic bond. It's kind of like a very specific type of molecular superglue. And you know those weird codes you see, like alpha 1,4? That's not as scary as it looks. It's just the instruction manual for the glue. It tells us exactly which way it's facing and where the two sugars are connected. Seriously, getting this bond down is the #1 key to acing this whole topic.
All right, let's talk about one of the most tested concepts ever, reducing versus non-reducing sugars. It all boils down to one super simple idea. Is a certain part of the sugar free, or is it locked up? See, a sugar is reducing if it has this one special part, the anomeric carbon, that's just kind of hanging out, free and ready to react. Lactose and maltose have this. But if that carbon is locked into a bond, like it is in sucrose, well then the sugar is non-reducing. I'm telling you, this one tiny detail is what almost every single question is trying to test.
Okay, look at this table. Seriously, screenshot it, write it down, whatever you need to do. This table right here is basically your holy grail for this topic in CUET. Let's break it down fast. Look at sucrose. It's glucose plus fructose. See that weird alpha 1,2 beta bond? That's the reason it's our famous non-reducing odd one out. Now look at lactose and maltose. Notice how their bonds leave one of the sugar units with a free end? Yep, that's why they're both reducing sugars. I'm not kidding. Burn this table into your brain. It's absolute gold.
Whew, okay, I know that's a lot of info. So the big question is, how on earth do you remember all of this when you're under exam pressure? Well, that's where we pull out the secret weapons, memory tricks. Let's build you a mental cheat sheet that'll make recalling this stuff a piece of cake.
You ready for this? Let's lock them in. For sucrose, just remember this. It's sweet, but its important carbons are stuck in a bond, and if they're stuck, it's non-reducing. Simple, right? Now, for all the reducing sugars, just think they are ready to react. Easy. And my all-time favorite is for lactose. Lactose is in milk, and what does milk do? It reduces your hunger. I know, it's super silly, but trust me, when that exam clock is ticking down, these silly little tricks are absolute lifesavers.
All right, team, you've got the concepts down, you've got the memory hacks in your back pocket, now it's time for the moment of truth. Let's put that knowledge to the test. Welcome to the CUET Question Gauntlet. I want you to get ready and solve these just like it's the real deal.
Okay, here's question #1. This is a classic. You're almost guaranteed to see something like this. Read it carefully. And go ahead and pause the explainer right now. Solve it. No cheating. I'll be right here when you're ready to check. Okay, you're back? The correct answer is, of course, C, sucrose. And why? Remember our trick? Sucrose is stuck. Its anomeric carbons are both locked up in that bond, so there's no free end available to react.
On the other hand, maltose and lactose both have that free anomeric carbon, which is what makes them reducing. Hey, if you got that one right, give yourself a pat on the back. Awesome job.
Ready for another one? Let's try a different format you'll definitely see. Matching. This one is all about remembering those specific bonds. Okay, you know the drill. Pause right here, match them up, and hit play when you think you've got it. All right, let's check your work. Maltose, that goes with B, the alpha-1,4 bond. Sucrose gets matched with C, that unique alpha-1,2 beta bond, and that leaves lactose with A, the beta-1,4 bond. See, this is exactly why I said that table from earlier is so important. It has all these answers right there.
Okay, now for a super important section. I really need you to listen up for this part. We're going to go over the most common exam traps, the little mistakes that make students lose marks they really shouldn't. Knowing these is your defense against losing those precious points.
Okay, listen closely. Mistake number 1, getting reducing and non-reducing mixed up. Remember, it's all about that free anomeric carbon. Mistake 2, mixing up the building blocks. A classic slip-up is saying lactose is glucose plus fructose. Nope, it's glucose plus galactose. Number 3, forgetting the specific bonds. Alpha versus beta, 1,4 versus 1,2, these details matter. 4, just completely ignoring the term anomeric carbon in the question. It's not just jargon, it's almost always the key to the right answer. And finally, the biggest trap of all, mistake number 5, thinking all disaccharides are reducing. They're not. Remember our old friend sucrose? It's the big exception. Don't fall for these.
All right, we're in the home stretch. It's time for a final 2-minute super fast revision to really lock all of this into your brain. This is the stuff you want fresh in your mind right as you walk into that exam.
Okay, let's go. Rapid fire. Sucrose, glucose plus fructose, non-reducing. Lactose, glucose plus galactose, reducing. Maltose, glucose plus glucose, reducing. What's the key factor that makes a sugar reducing? A free anomeric carbon. And what's the most asked question on this topic? Which sugar is non-reducing? The answer is always sucrose. Seriously? Get your phone out and screenshot this slide right now. This is your ultimate last-minute cheat sheet.
So, I gotta ask, how did you do in the question gauntlet? Did you nail it and get a perfect 2 out of 2? Or maybe 1 out of 2? Hey, either way, be honest and drop your score down in the comments. There's no judgment here. Let's see how everyone's doing and support each other.
Look, by spending this time with me today, you've taken a massive step forward. You're not just studying, you're actively working on becoming a CUET topper. If this explainer cleared things up for you, then join the crew and hit that subscribe button. We're going to be breaking down all the other high-yield topics just like this, one by one. You've totally got this. Keep up the amazing work, and I will see you in the next one.